Hello everybody, welcome or welcome back. In today's video we'll be seeing one of the methods to convert hard water into potable water basically, so that is by removing salts. So that is by ion exchange method. So basically what are we doing? We are converting hard water into potable water. Now why is this hard water? Because it has salts. What kind of salts? It has calcium and magnesium salts. CaCl2, MgCl2, CaSO4, MgSO4, CaHCO3 twice, NgHCO3 twice, such kind of salts. Basically calcium and magnesium salts. Now ion exchange method. What is going to happen here? The ions are going to be exchanged. That we have understood. Now let me just draw pictorial representation. Okay, say this is the cation exchanger, not say this is the cation exchanger, and this is the anion exchanger. And the water flow also I'll just show you now only. Hard water is going to enter through this, and potable water is going to exit through this. Okay, and the next labeling is that this is basically polymer which is made of candle or bed, whatever like that, and this will have RH plus, and this will have ROH minus. This much you have understood. Here R is polymer, H plus is exchangeable H ion, and that is R is polymer again, and OH minus is exchangeable anion. So this much everything is clear till now. Basic diagram I am drawn, nothing hard, nothing complicated. This is the cation exchanger, this is the anion exchanger. Now one more thing, I'll just write salt representation here. Okay, salt is represented as M plus X minus, where M plus is the cation, X minus is the anion. Okay, what is going to happen is that first, when we pass the water containing salts, basically hard water, into this, the cation, that is the M plus part, is going to be replaced by the H plus, and when it comes to the anion exchanger, the X minus or the anion is going to be exchanged with the OH minus ion. This much you understood? This much did you understand? Okay, now let me show you in reaction wise. So firstly let's observe cation exchanger, which is first cation exchanger only will come. Okay, here what did we have? We have RH plus, correct? And what is the salt? M plus X minus. This is the salt is represented by this only, correct? And RH plus is the what is already present, polymer, whatever it has, this whatever is inside this is RH plus only. Now what did I say? Cations are going to get exchanged. That's going to become what? Rm plus H plus. Do not worry about X minus here. Rm plus H plus. It's going to become like this. Now let me take an example and show you. Suppose let's take any calcium salt, say CaCl2, anything. Okay, now basically cation part we want. So RH plus Ca2 plus. Okay, we know we have to get Rm, which is basically RCa, but 2 plus is there, so that's why we are going to write 2 here. Remember, 2 plus is, that's why we are going to write 2 here, not Ca2. It's going to be R2Ca. Okay, plus H plus. That's it. Cation exchange done. Similarly, one more example, RH plus Mg2 plus. What is it going to become? R2Mg plus H plus. Sorry, here 2 is there, so this will become 2 and 2H plus. So here again same 2H plus. So here also 2H plus. That's it. Hydrogen is released here. Keep it like that. Okay, I'll tell you what should we do with that. Okay, now coming to anion exchanger. Here also what do we have? What did we have there? ROH minus. See, ROH minus. This is already there. This is the polymer part, and this is the exchangeable hydrogen. This is the polymer part. This is the exchangeable hydroxide ion. So hydrogen and hydroxide ion. So this is what? ROH minus. And same M plus X minus salt. Here what is going to get exchanged? The anion part. So Rx plus OH minus, Rx plus OH minus. Example, let's take suppose CaCl, right? So Cl minus will take ROH minus plus Cl minus. I'm only consider about the anion part. I'm not taking Cl2 minus, Cl2 minus. Cl minus only I'm taking. This any valence is there? No. So RCl plus OH minus. One more example, SO4 will take. Now SO4 2 minus will come. So that also just remember the standard examples and go. So this will become what again? R2 SO4 because Rx, and then OH minus. This will become 2 and this will also become 2. Correct? That's it. Now here OH minus is released. So H plus from cation exchanger and OH minus from anion exchanger will give you water. This is what deionized or demineralized water. Deionized or demineralized water. Now, which is in brewery industries and all of that, after several usage of this ion exchanger, it has to be replaced because the ions which are present, right, they would have also got they would have also gotten over, they also have a limit, right? They would have gotten extinguished or whatever. So we have to replace the entire ion exchange system. But in case of like laboratories or experiment purposes, we can use regeneration method because they're not consuming it, right? So we can use regeneration method. So first what we were trying to do, there was already an RH plus. From RH plus we got Rm. This is by what? This is by cation exchange method. There was ROH minus. We got there was ROH minus. What did we get? Rx. This is by anion exchange method. Now we want back these two because then only we can again further we can further convert hard water to potable water, right? So how are we going to do that? First let's see the cation exchanger part again. Cation exchanger, how do we get back cation exchanger part? Rm we have, we are going to make it dissolve with it. We're going to wash that part with some very dilute acid. So H plus Cl minus is there. We got back our RH plus. For anion exchanger, Rx is there. We can wash it with base. So NH4 plus OH minus. So OH minus, that will become ROH minus. So we got back this. Again this we can use within cation like Ca2 plus, we will get R2Ca plus H plus. And this again we can use it with the base. We can then we'll get ROH minus plus SO4 2 minus. So R2SO4 plus OH minus. So then we can regenerate for experimental laboratory purposes. But for brewery industries, it's better to change the entire system instead of regeneration because it's for consumption purposes. So this was all about ion exchange method. I hope I have done well. So you can give me your feedbacks, and for most videos, see you in the next one. Bye bye.